Voila. Hey, this question here, determine how many moles of AlI3 are obtained from a reaction using 10 moles of I2 and excess aluminum. That means we have more than enough aluminum and a certain amount of I2. So we're trying to find the moles of AlI3. So I'm just going to write this down here. We have 10 moles of this, and we're trying to find the moles, the x moles of AlI3. That's an L, by the way. So this is what we're trying to find. If only we knew the ratio of moles to moles here. Well, first thing we got to do is we could balance it, and if we do, we have a ratio between the number of I2 particles or iodine molecules and aluminum iodide. Okay, so let's balance this first. I see I have a 3 here and a 2. That's going to be a little bit tricky. The only way to get these two to equal is to make this 2, which will make that 6 iodines, and then make this 3, which will make that 6 iodine atoms. So that's going to balance. Now we have 2 Als here, so we got to balance it with a 2. Okay. And there we are. So this problem, if we have 3 moles of iodine, how many moles of AlI3 do we get? That's right, 2. It's just like Dora the Explorer. What if we had 30? How many do we have over here? That's right, 20. And how many of these? 20. See, the ratios of the moles, the ratios, the number, the stoichiometric coefficient, the number in front of these these molecules and atoms, tells you how many of this per this per this give you this. So it's a recipe. So let's figure it out. You could do it in your head if you wanted, but let's just solve it properly so you can have the tool for later. Start out with the moles that they give us, 10 moles of iodine, put on top, over how many moles of AlI3, so over x moles of AlI3. I like to put over what I'm solving there. Okay? Same units on the top as the bottom, moles of I2 over AlI3. And then the ratio, there are 3 moles of I2 for every 2 moles of AlI3. So it's 3 halves. So what is about 2/3 of 10? That's about 6.6. But let's do the math just to see. This times this divided by this. This is a straight up conversion factor. Look how moles of iodine cancel. That's how you know you did it right. 10 times 2 divided by 3 is about 6.7 moles of AlI3. Remember, it's 2 significant digits. I'm just assuming that this is 2 significant digits. Usually it's 2 to 3. Okay? And that's what it is. If you wanted to double check your answer, put 6.7 in here, and this should be the same. 10 divided by 6.7 should be 3 divided by 2. Not too bad. Remember, you don't need grams, you don't need molecules, all you need is just the mole ratio when you have mole to mole problems. Got it?